Okay, this is example 3. Okay, you have your heat exchanger icon here. Okay, so heat exchanger is used to heat flammable volatile solvent as shown in figure 2. Okay, so this is figure 2. Okay, the temperature of the outlet stream is measured by a thermocouple, and a controller valve manipulates the amount of steam to the heat exchanger to achieve the desired set point temperature. Okay, you have your control valve, steam going in, okay, and volatile solvent also going in through valve number 1, and also and with control by the steam. Okay, so identify the study notes of the process. Okay, the cold solvent line to heat exchanger. Okay, try to identify which one is the cold solvent line to a heat exchanger. Hot solvent line from heat exchanger. Where is the line of steam line to condenser? Condensate line from heat exchanger, and control loop. Okay, then by performing HAZOP study on intention of hot solvent from heat exchanger. Okay, so this is heat exchanger. Okay, this is your heat exchanger. Cold solvent line to heat exchanger. So the first one is cold solvent line. Okay, the line where carried a cold solvent into the heat exchanger. So this is the one. Okay, cold solvent line to heat exchanger. Okay, the second one is what is the line carrying hot solvent from heat exchanger. So going out. Okay, going out is the one that carrying hot solvent line. Okay, because this is the solvent line. So one is going into a heat exchanger, another one is carrying from heat exchanger out from, okay, carrying out from heat exchanger. Then a steam line. Okay, a steam, this is steam, so this is the steam line. Okay, steam line to condenser. Okay, then you have the condensate line. Okay, this is the condensate line. Okay, from heat exchanger. So this is the heat exchanger itself with the control loop. Okay, this is the control loop. Okay, this is the control loop. You have thermocouple and so on. Okay, you have your thermocouple and your control valve. So by performing HAZOP study on the intention of hot solvent from heat exchanger. Which one is hot solvent from heat exchanger? Okay, this is your solvent. Hot solvent from heat exchanger. So this is your notes. Okay. Okay, we see how they solve it. Okay, so you solve line from hot solvent from heat exchanger. Solvent line from heat exchanger. This is your note. Okay, this is your note. Okay, this is your note. So when this is your notes, all your HAZOP studies will concentrate or will focus on this area. Okay, so we start with process parameter of flow. Then you have your guide words of no, more, less, and so on. Okay, with no flow, what is the possible causes? Okay, then you have the possible consequences and also the action required. Then you change, okay, your word. Okay, you change your guide words. Okay, using more flow. Okay, from your solvent line of heat exchanger. So what is the cause of more flow of your solvent? So your solvent supply, okay, your solvent supply pressure increase. Okay, so what happened? The high solvent flow will make a possible downstream process upset. Okay, downstream process upset. Okay, means the downstream process, the next process. Okay, then you have your less flow and so on. Okay, just make sure you have your action required or recommendation action is linked back to your possible causes. Okay, then you have your possible consequences is related to your possible causes. Okay, you see, same as one for the same consequences but different possible causes. Okay, so basically this example are using solver line and then using process parameter of flow. Okay, but you also can use another process parameter after you have done this analysis. Then you have solvent line from heat exchanger, but the process parameter is temperature. Remember, because this is a heat exchanger and they are carrying hot. Okay, when the design intent has some relationship to another process parameters, then you can use it in your HAZOP studies. So your solvent line from heat exchanger with process parameters of temperature. So what happens if there is no temperature? Means there is no change of temperature, or maybe there is no heat inside your solvent line. Okay, what happened? Then you have your possible causes and consequences and so on. Alright, so this task need a little bit of brainstorming, okay, to find the causes, consequences, and also recommendation action. Okay, this is the last example for HAZOP studies. Example 4 is based on diammonium phosphate, okay, DAP, diammonium phosphate. Example, okay, phosphoric acid and ammonia are mixed and a non-hazardous product, DAP, diammonium phosphate, result if the reaction of ammonia is complete. If too little phosphoric acid is added, the reaction is incomplete and ammonia is produced. But if too little ammonia available to the reactors, result in a safe but indesirable product. So both chemicals will be used in large quantities and in concentrated form. Due to highly corrosive nature of both chemicals, the project team was assigned to investigate the hazard posed to staff. Okay, the hazard posed to staff from the reaction resulting from study line 1. Okay, so you will see this is the process. Okay, this is the flow diagram of the production of DAP. Okay, diammonium phosphate. As you can see, this is your study line. This is your node. Okay, this is your study node going into a reactor. Okay, you have your ammonia, you have your phosphoric acid. So your intent or your node is inside this line. Okay, because your intent is to study the hazard posed to staff from reaction resulting from study line 1. Okay, this is study line 1. Then what will happen? Okay, using the guide words, okay, of no, less, and more, and so on. But okay, inside this report, there are some mistakes. Okay, all right. Okay, now, okay, the flow or the process parameter has been identified or has been notified inside the process or the HAZOP studies information. Okay, so it just focus on flow of this study. Okay, the flow of phosphoric acid delivery line. So the flow with guide word no will cause a deviation of no flow. So this deviation section, okay, you see previously there is no deviation form. Okay, but this one have a deviation. So this deviation part is an optional. Okay, just to highlight, no flow. Okay, less flow and so on, more flow. So the consequences, possible causes, and recommendation still been listed inside this report. Okay, so there is no flow in the line. So what will happen? Okay, okay, the consequences is the excess ammonia in reactor will occur, okay, and release to work area. So this is the consequences to the workers. Okay, so what is the possible causes above valve A fails closed, phosphoric acid supply exhausted, or pipe ruptured. Okay, but the reaction required is automatic closure of valve B on loss of flow from phosphoric acid supply. Okay, they take action on valve B, okay, to prevent these causes. So if you are referring back from previous HAZOP studies, this action basically does not refer to what is their exactly possible causes. Okay, so which one or which action of this action required or action being taken will solve these possible causes? Is it number 3? Is it number 2? Or is it number 1? That's why you need to make a number for your possible causes, your consequences, and also your action required. Even though it is the same action or the same recommendation from your analysis or studies. Okay, because these consequences have been contributed by why? Is it by valve A fails close, or is it phosphoric, or is it a pipe rupture, or is it the combination of these 3 possible causes? Okay, that's why we need to make a little bit systematic. Okay, a little bit systematic, so that you can go from one possible causes to possible consequences, and then the next or the action required. Okay, so you can make improvement on this report. So there are a few advantages of HAZOP. Okay, it can provide the detail of HAZOP studies that can help the companies to process or operate better, higher product quality. Okay, as previously we see the effect or the consequences of the fault is towards the desired product, okay, or the desired quality product for the process. So you can increase your product quality, you will reduce your waste, okay, that have been produced, and also your employees are more confident in your process safety. Okay, so our next lecture we will look on what is safety reviews, and we will try to summarize all of these hazard identification techniques so that we know which one that we can apply for that certain scenario. Okay, that's all for today. Thank you for listening to me, and hope that you can understand. And if you have any question, any problems regarding these topics, you can ask your question in elearn@usm.my, or also you can also ask question inside our Telegram group.